Okay, page 328, key concept, 6-5. Did you know? Key concept. Here we go. Two-dimensional figures. They're congruent if there is a sequence of translations, reflections, and rotations that maps one figure on top of the other. Again, we just proved that it's congruent by moving a shape directly on top of the other one. If it fits directly on top, it's congruent. If not, they're different size, different shape. They're not congruent. So, how does a sequence of translations, reflections, and rotations result in congruent figures? Well, a sequence maps one figure to another through multiple transformations. And again, I'm using the word transformation to indicate we are translating, reflecting, or rotating. Okay, number 2, does a sequence of transformations have to include, the key word here is have to include, a translation, a reflection, and a rotation? Is everything we've done have to include all 3 of those? No. Just have to include, have to have one or more transformation. So, there's sometimes we can prove congruence with only one thing. We could translate an object from one spot to another spot and just prove congruence through that. Sometimes it takes more. Could take 2, could take 3, could take 12. Who knows? But it has to have one or more. Doesn't have to have all 3. Let's just jump over to number 4 right now. A rectangle with an area of 25 square centimeters is rotated and reflected. What will be the area of the resulting image? Well, if we reflect something and then we rotate something, is the size or shape going to change? No. So if it was 25 square centimeters, it's still going to be 25 square centimeters. Explain. Okay? Rotations and reflections do not change the size of a shape. So, if it was 25 square centimeters, it still is. Mm-hmm. All right. Number 5. Use the coordinate grid below. It's asking, is triangle ABC congruent to triangle DEF? Triangle ABC congruent to triangle DEF. Well, let's see. Let's use a sequence of transformations to see if this figure will map on top of the other one. Now, at first glance, it sure looks like it's the same size and shape, but let's prove that it is. Let's start with the first thing. Now, in the lesson they talked about, let's translate, okay, corresponding points on top of one another. Now, I know point C corresponds to point F, so let's translate point C to point F. Okay, so let's translate up. Translate up, how many units? Well, let's go 1, 2, 3, 4, 5. All right, so if we translate up 5, okay, now there is point C. Let's see, point B would be 3 units to the left of point C, and point A would be left 1 and up 2 from point B. So now we have our shape like so. This sure looks like some type of reflection because the orientation of that shape has changed. So let's reflect. Now, what line are we going to reflect on? I don't want point C or point F to move. I'm going to draw it. I'm going to draw it. There it is. I just drew that blue line. If I reflect over that blue line, point B is 1, 2, 3 left. It's going to end up 1, 2, 3 to the right. Ooh, there's point B now. Point A is 1, 2, 3, 4 to the left. Oh my goodness. I did it. I did it. Now, we just need to name that line of reflection. It's one of those special case ones. It's not the x-axis or y-axis. It's a line that goes through the x-axis at what number? 5.
5?
There it is. So, are those congruent? Yes. Our explanation, there's our sequence. We just proved it. Number 6, let's get rid of this stuff. Now we got to prove, is ABC, triangle ABC, congruent to triangle GHI?
Yeah.
GHI.
Wait
ABC,
a second.
GHI. Well, the way it's named, how about let's translate some shapes. Let's translate letter C onto letter I. C comes last, I comes last. Let's translate it.
Wait a second. Do we even need to do that, Mr.
I
Moore?
don't know. Do I need to waste my time through trying to show? Or can we look at this and go, not
Can't we
same
look
side
at some
C.
side lengths here?
You want to just look at side lengths?
Look at side BC. How many squares
side
is that?
BC. It's a 3.
Okay.
Now, what would be the corresponding side to side BC?
But just look at the name.
Look at the name.
Yeah.
BC,
Hi.
HI.
Hi. Is
Well, this is 1, 2, 3, 4.
Oh.
That sure don't look like it's congruent. No. Why not? Side lengths are different. And there, folks, is page 328. We did skip number 3. You can do it if you want. But if we're going to make something identical in orientation, there may have to be a reflection involved in there somewhere. Anyways, page 328, there you go. Mr. Fricke is coming up next with your favorite 6-5 additional practice.